Hello, great people. Welcome to today's math class. We have this equation before us. The question we solve for a in a to the power of the square root of a equal to 10. What is the value of a that will actually satisfy this equation here? So let's take our solution here. But before we go into today's solving, then if you new here, this is Math Pro is. If you've not subscribed, consider subscribing. And when you subscribe, do not forget to hit the notification bell so that you get notified by the YouTube algorithm whenever we release an amazing video. So, what we do here now? Now, we want to see a way whereby we can express the left-hand side of the equation to be same with the right-hand side of the equation. For doing that, we pose some challenges. So all we need to do is to rewrite this base alphabet here. How? If we decide to write our square root of a or in bracket, then put in square here raised to the square root of a. This is same thing as what we have in here, because this radical will take care of this power here, and we're going to have a here, right? Good. So what we do now, according to the law of indices, we say that if you have your a to the power of your mn, this is equal to your a to the power of your m bracket n. We can rewrite this expression because this is power, this is power. So we can separate this out. If we separate this out, it's going to give us the square root of our a in bracket or raised to the power of 2 in here, then all further raised to our square root of a here. This is equal to our 10. We can use this to multiply this according to this law again. And so doing that, this will give us the square root of RA bracket bracket 2 into the square root of A equal to 10. Yeah, we're going to do some simple substitution here. So we can say here, let the square root of A equal to x. So wherever we see square root of a, let's put in x there. So if we go by that, then we're going to have this to be our x to the power of 2x equal to 10. This is easy, right? Good. Now, with this, we want to ln both sides of the equation. If we decide to take log to base 10, that will give us some trouble. And so we want to apply the ln base e. So applying the ln base e to both sides of the equation is going to give us here the ln of our x all to the power of 2x. This is equal to the ln of our 10 in here. According to the law of logarithm, we say that if you have ln of your a, okay, or raised to b, then move this to this side. So this is going to give your b times the ln of a. So if we apply this law here, what will happen? We're going to move the whole of this power back here. So this is going to give us our 2x times the ln of our x. This is equal to ln of 10. Good. At this point, we want to divide by 2 so that 2 can leave the system course of what we want to evoke into the system, which is what we call the Lambert NW function. So we divide through by 2, divide this side by 2 also. So this and this leave the system. We are now left with our x times the ln of x equal to the ln of 10 all over 2. Are we learning something? So if we are gaining value from these math solutions, do not forget to subscribe because we're going to release more of these math solutions in subsequent time. All right, so let's continue here. Now I want to rewrite this expression here, x here. If you are familiar with this law, we say that if you have your e to the power of ln of, let's take a, this is equal to a, because this is ln base e, and so this goes with this, and so we have this. So if we apply this, we want to rewrite this x here. So rewriting this x, we're going to have this to be our e to the power of ln of our x times ln of x equal to the ln of 10 all over 2. Easy, right? Good. Then from here, let's just rearrange this. So this is going to give us here, or we can say this now implies our ln of x times our e to the power of ln of x equal to ln of our 10 all over 2. So now let's look carefully. From what we have here now, remember that there is a law which is known as the Lambert W function or the product law. It says that if you have your A times E all to the power of A, and we decide to take the Lambert W function, this is going to give us our A, right? So here, what we have at the base here is what we have at the power here. And so look at what we have here. What do we have at the base here? Same thing we have at the power here. So we can easily take the Lambert NW function, or which is what we know as the product log. And so this is going to give us our W of our N ln of x times our e to the power of ln of x bracket equal to, we take the same w of our ln of 10 close bracket all over 2. So this will end up giving us our ln of x equal to the w bracket the ln of our 10 close bracket all over 2. We have to eliminate these ln here because we are looking for our x. And so we bring e into the system. Again, remember that your e to the power of ln, this will give us what? 1. So if we are to eliminate our ln here, then we're going to bring it e to the system. So we're going to have e to the power of ln of x. This is equal to our e to the power of the w bracket ln of 10 close bracket all over 2, right? Good. So from here, this go with this. So now have our x will now be equal to the e to the power of w, the bracket ln of our 10 close bracket all over 2. So we have a nice solution to this expression here. If you impute this into your Wolfram Alpha calculator, it will give you a numerical answer or value that will actually satisfy the original equation. So this brings us to the end of this math class. If you gain some value from this math, then drop it in the comment section. And do not forget to subscribe to our channel for more solutions to math problems of this kind. Remember, this is Math Prowess. We love you. Thanks.